Welcome to Building UIs in the Terminal with Python Textual. My name is Christopher, and I will be your guide. This course is all about the Textual third-party library, which you can use for building interactive programs in your terminal. A program that uses Textual is known as an app. Inside the app, you use different kinds of widgets to compose an interface. Textual supports a wide variety of widgets, so this course will cover just some of the key ones, like those used to display text, as well as buttons and user input. Similar to their GUI cousins, terminal applications, like those built with Textual, are event-based. Your code gets triggered based on an event like the user pressing a button. Textual also has a way of writing less code for event handlers known as actions. Both of these get covered in this course. This course was tested using Python 3.13.5. Python 3.14 was out at the time of recording, but Textual had not yet released a compatible version. That said, I've used Textual fine with 3.14, only the debugging console had an issue due to the changes in how async code works in 3.14. The Textual libraries I used were the core 6.2.1 and the development kit for debugging 1.7.0. Textual is a TUI framework. That's TUI for Terminal User Interface. A TUI is like a GUI, an interactive program made up of widgets. TUIs achieve this by using terminal control sequences to position blocks and lines. Of course, that means the interface is a little chunkier than a pixel-perfect GUI, but you'd be surprised just how much you can accomplish. By focusing on the terminal and being a Python library, your TUI is more or less independent of the operating system. Different OSs come with different terminals, so you may have restrictions on how many colors can be used at once, but for the most part, if you can open a terminal, you can use a Textual application. Textual is a robust framework coming with pretty much anything you need to build your TUI, including a large number of widgets. And proof of that is just how many Textual applications are out there. I've seen everything from a Postman clone to a piano. But this course isn't about using Textual apps, but building them. You'll learn all about how to write and style an app and how to compose widgets together to create your own TUI. Next up, you'll hit the ground running with a Textual Hello World. In the previous lesson, I gave an overview of the course. In this lesson, I'll show you how to get started with Textual and write your first app. You create a Textual app by inheriting from Textual's app class. You subclass the app and override certain key methods to create an interface. Then instantiate your class and call its run method to get it going. Your app will be comprised of widgets, some of which are interactive, like buttons, and some which aren't, like text labels. You tell Textual what widgets you want by defining a compose method. Inside of that, you yield the widgets you want to include. Once you've done that, the built-in run method takes care of everything else. Since Textual is a third-party library, you'll need to pip install to get it going. As always, you should use a virtual environment when dealing with third-party libraries. I won't show it here, but if you want to see what Textual is capable of, you can execute the Textual module using Python-M once you've got Textual installed. Running -M Textual starts a demo application that shows off the different widgets and features. Let me go open an editor and show you a Textual Hello World application. These 11 lines are all you need for your first Textual app. It isn't particularly fancy, but hey, Hello World isn't meant to be rocket surgery. To build a Textual app, you need to define a class that inherits from Textual's app class. The Widgets module is where you find a rich set of widgets that you can use. No pun intended. You'll get that later. There are a couple of different widgets for displaying text. For your first app, I'm going to use the one known as static, as in static text. As I've said, you declare an app by inheriting from Textual's app class, which is what I've done here. And then the compose method is where you declare your interface. Whatever components you want are created here. Note, this doesn't actually display the components, it just registers them for later. In a later lesson, I'll demonstrate how you have one more chance to do things to your widgets before the app gets displayed. Textual treats the compose method as a generator. When the app gets started, it uses the objects sent out of the method to create the interface. If you've never played with generators before, you don't really have to understand how this works under the covers, as long as you know you need to yield each widget that you want in your interface. The only widget in this first app is the static text widget. Here, I'm constructing a new instance, passing in the text I want to display, sticking with tradition, and that text is Hello World. As this script is both declarative and runnable, I'm nesting the running part inside of a dunder main check. If you've never seen this before, dunder name gets set to dunder main when your script is run from the command line. If this file were merely imported, this if clause wouldn't get triggered. For a textual app, this isn't really all that important. You're almost always using it as a script, but I'm sticking with best practices here. To run your TUI, you simply need to instantiate your new app class, and then call its inherited run method. Let's try this out. Running the code, and there you go. You've said hello. There's not much to see here, but notice a subtle difference from, say, just printing out the string. If you had printed the string out, the text would have appeared below the execution line. The reason Hello World is at the top here is because Textual clears the terminal and the application takes over the terminal window. For me, this is in my sub-window below the line, but it's taking over everything it can control. To exit a textual application, you press Ctrl-Q. I actually don't really like that, and we'll show you how to change it later, but for now, let me Ctrl-Q to get out of here. Okay, you've seen your first app. In the next lesson, I'll dive a little deeper into displaying text widgets on the screen. In the previous lesson, I showed you the Hello World version of a textual application. In this lesson, I'll play around a little more with text widgets and show you some of the styling you can apply to them. Every displayable component of your TUI application is a widget. So if you want text on the screen, you can't just print it, you need a text widget. The two most common text widgets are static, which you saw in the previous lesson, and label. For the most part, they're similar to each other, they just behave slightly differently when laid out. Label widgets, by default, are the size of the text they represent, while static widgets take up the space of their holding container. You'll see the difference in a sec when I give you a demo. The creators of Textual are also the creators of the rich text library. Like with rich, the text contents can be specified using a markup language. Most text you type is just text, but you can put styling commands inside of square brackets to change how the text is displayed. For example, square brackets bold red changes the text to bold font and colored red. All widgets have a styles property, which allows you to programmatically get and set the style of the widget. The styles property itself has properties, which are the things you change. Some common ones are background, which controls the widget's background color, border for specifying an outline, text align for centering or right aligning text within a widget, padding for determining the spacing within the widget, and margin for spacing around the widget. If you're familiar with CSS on the web, these styles might be ringing a bell. Textual uses a subset of CSS to control appearances, and so if there's some styling you can do in CSS, you'll probably find it in Textual as well. In a regular Python script, the code gets executed line by line. If I have 3 print statements in a program, they run exactly in order. Of course, when you start building functions, this changes a little. The declaration order of the functions isn't necessarily the running order. TUIs and GUIs are similar. You typically want code to fire when the user does something to the interface. How most TUIs and GUIs accomplish this is with an event system. You create an event handler by declaring a function or method and register it against that event. When things happen in the TUI, events fire, and any associated handlers get called at that time. Typical events are things like the user pressing a key or clicking a button. There are also system-type events that aren't user-triggered. For example, Textual fires events when a widget gets put into or removed from the interface. This allows you to dynamically change things during the execution of your program. Textual gives you several ways of declaring event handlers. The first one I'm going to show you is the built-in on prefix. For example, the onKey method gets called for each key press, while the onMount method gets called when the application mounts the widgets. This is after the compose method fires, allowing you one last chance to do something with your widget before it gets shown. Let's go play with static and label widgets some more. This new app has two text widgets in it, one static and one label. I'm going to get a little fancier than Hello World and show you some of the things you can do to style your text. In the previous lesson, you saw how you have to yield a widget inside of the compose method to register it with Textual. That's required, but you can create and store a reference to the widget before yielding it, like I'm doing here. This allows me to access the widget later on in the code. I'm instantiating this static widget with some textual markup. Inside of the string, I've got square bracket style indicators. This will turn the text bold and red. That style applies to this word, and then square brackets with a slash are what turns it off. Anything after this closing tag will be back to normal. When you close the tag, you don't have to turn everything off. I could have turned off just the bold, and then the rest of the sentence would still be red if I had wanted. Once I've constructed the object and kept a reference to it, I yield the reference to include it in the interface. Here, I've done something similar with a label widget. Note the use of the closing shortcut here. Square bracket slash means to close all open markup tags, so this will turn off the yellow and italic, and that means you don't have as much typing to do. When you run a textual application, it calls your app's compose method to determine what to show on the screen. When it's ready to go, it fires the mount event. This is done in two steps because some of the properties of widgets aren't known until all the widgets have been created. Depending on how you're laying things out, the size of some widgets can affect the size of others. The mount event is fired after all this has been figured out and gives you a last chance to modify the properties of your widgets before they get displayed to the screen. For the core app events, you can register an event handler simply by overloading their on method in the app. Here, onMount is what gets called when the mount event fires. And this is why I kept a reference to that static widget that I built in the compose. It means I can access it here and make changes after the compose is run. The first change I'm applying is by setting the background property on the styles property, making our widget blue. The border property takes a tuple. The first value in the tuple describes the style of the border, where solid means a solid line, and the second value specifies the color of the border. Setting text-align to center centers the text in the widget. If you've done CSS before, be careful to note the difference here. Python doesn't support hyphens in property names, so anywhere where you would use a hyphen in CSS, you need to change it to an underscore. This will get a little confusing later, and I muck this up all the time, but you have to kind of keep it in mind. The padding property specifies the spacing within the widget. The value of 1, here says to put a one-line space above and below the text, as well as a one-character space to the left and right of the text. Other parts of the layout may cause there to be more padding than this, so consider this a minimum. The margin property specifies the spacing around the widget. 4 means 4 lines above and below, and 4 characters to the left and right of the widget. Again, the layout could make it bigger than this, so once more, it's a minimum. Similar to the styling for the static widget, here I style the label, this time making the background color dark green and using a double-lined border in red. When you press a key on your keyboard, Textual fires the key event. You can override the default onKey method to do what you like with those key presses. Here, I'm using a pattern matching block to react to the key property on the event object passed into the handler. If you haven't seen these before, they were introduced in Python 3.10, and they serve a similar purpose to if-else blocks. The argument to the match statement serves as a value to look for, then the case statement works like an if equals statement. If the value inside of event key is Q, then this case runs, and so the exit function will get called. In the previous lesson, I mentioned I don't really like Control Q to quit, and so now I've got it set, so pressing Q will be enough. Below this method, I've instantiated the app and called its run, just like before. Let's try this out. And here you have the app. Static widgets fill the container, which in this case is most of the screen. It's actually all of the screen, but the margin property of the widget is keeping a 4-character boundary all around it. The label widget by default is only the size of its contents. Of course, the padding within it and the border property affect its size, but it doesn't get any bigger than that. It also has a margin around it, which is why it's offset. And since I added the key event handler, I can press Q to quit. Next up, more on styling and how to use CSS to control your app's appearance. In the previous lesson, I showed you how to style text widgets using the styles property. In this lesson, I'll show you the power of Textual's CSS mechanism. Textual supports a subset of the cascading style sheet interface used to style web pages. They call the subset TCSS. Although I do a lot of web dev, I'm not really a fan of CSS. It feels like a Jenga tower of hacks to me, with each release trying to compensate for the fact that the last release didn't fully compensate for the one before it. Textual's use of CSS is why it took me a while to even try it out, but the library builders have chosen the right parts of CSS. In the previous lesson, you saw how to use the styles property to individually change a widget, but by using CSS, you can achieve the same thing with far less code. Like with the web, you can specify CSS separately from the components, and then the styles get applied to your widgets. You can specify style rules based on the Python class of the widget, the ID associated with a widget instance, or by creating a CSS class with a string. The first and last example of these mean you can create styles that are consistent across your interface for multiple widgets. For example, changing all buttons or all of the widgets with a certain CSS class label. One of the things I still don't like about CSS is debugging it. I never seem to get the layout right the first time. Textual helps with this as well. So far, you've been running your apps directly from Python, but you can also use the textual command to run them instead. If you do, and use the --dev flag, Textual will update the interface on the fly while you edit the CSS. You don't have to exit and restart the program, you simply make the change and watch its effects. To use this feature, you need a separate library, Textual Dev. You pip install it like any other. And once you have, you can invoke your app either with Python directly or through the textual run command like I'm showing here. Let's go write another textual app, this time using CSS to style it. I'm still sticking with static widgets, but this time I'm going to style them with CSS. There are several ways of associating TCSS with your app. The one I'm using here is setting the CSS path class property, giving it the name of the file where I'm going to define my CSS rules. Like before, I'm yielding components, this one being a vanilla static object. And here I'm yielding another one, but this time I've set the ID argument. Now this object can be associated with ID-based CSS rules. Here, instead, I'm declaring a CSS class. You do that with the classes argument, which takes a string. This object will respond to CSS class rules named static CLS1. A widget can have multiple CSS classes. You do that by passing in a space-delimited string. This object has both the static CLS1 class like the one above it, and a static CLS2 as well. Now let's look at the associated TCSS file. A CSS file is comprised of rules. You start by specifying what objects the rules apply to. Here, the capital S static means this style applies to all widgets of that type. You then use brace brackets to denote the block of style properties to apply to objects that meet this rule. All of our static widgets will have a blue background and one line and character of padding around them. The hash mark, also known as octothorpe if you're not on a first name basis, indicates an ID. So hash static with ID means apply this rule to the widget that has this ID. And the style I want to apply to the object is to give it a white border. A period means this rule applies to a CSS class. All objects with this CSS class get these rules. The C in CSS stands for cascading, which in this case means a sort of inheritance. The widget that this class applies to is also a static widget, so the top rule and this rule will apply. The rule about an object's CSS class takes precedence over the rule about the Python class, so objects of this CSS type have the background property of blue overridden to become green. You'll recall that one of our widgets has both of our CSS classes applied, so that one will have both a green background from the other class rule and a dashed yellow border from this one. Let me fire this up in a terminal so you can take a look. Okay, I've got my editor open on the left. Now let me run the app using the dev flag. As you can see, our 4 widgets have 4 different styles. This static CSS rule applies to all of the widgets, making this widget and this widget have a blue background. The other 2 don't because other rules override it. Our 3rd and 4th widgets have the static class 1 CSS class applied, which is what overrides the blue and turns them green. The 4th widget also has the static CLS2 applied, which is what gives you the yellow border. Since I ran this app using the textual run command in dev mode, I can live edit this style sheet. As soon as I save this, the app on the right-hand side gets updated. This is great for debugging. A very common trick when you're trying to figure out if rules are getting applied is to add a red border around the thing you're trying to debug. This often also makes the padding and the margins clearer as well. By being able to do it live, you can muck around until you understand what is going on and make whatever fixes you want. So far, you've only seen widgets that do nothing. In the next lesson, I'll show you a couple of widgets with which your user can interact.